Yes, sir.
The equivalent relation, if a relation is reflexive, symmetric, and transitive, then it is equivalent relation. Partial order relation, reflexive, antisymmetric, and transitive. Right?
Yes.
Then can you give an example of equivalent relation? Equivalent relation on finite sets. Can you tell me what are the finite sets? Can you tell me finite sets? Parent sets. Parent sets can be finite sets or infinite sets. If we use infinite set, what is a good example for that? The parent sets you can take as real number sets or set of integers or finite set. Finite set. These are good examples. Can you propose a finite sets? Let's say A is finite set. I will take 1, 2, 3, 4, 5, 6, 7, 8. Right? 7, 8. Now, can you write down an equivalent relations? R E is equivalent relation. How do you write equivalent relation? There are many relations, equivalent relations. Equivalent relations should include 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. And it should be symmetric also. 1, 2, 1, 2, 2, 4. If 1, 2, 2, 4, then 1, 4 should be there, no? If it is transitive. And 1, 2 is there, then 2, 1 also there, no? 2, 4 is there, then 4, 2 also there, no? If it is symmetric, right? Now, if you take 1, 2, now, is this symmetric? Is this something symmetric? 1, 2, 2, 4, 1, 4 is there. 1, 4, 4, 4, 1, 4 is there. 2, 1, 1, 1, 2, 1 is there. 1, 4, 4, 1, 1, 1, 4, 1, 4 is there. Okay. Now, so you should be, if AB is there, then BA also there, right? Okay. If and so this symmetric property, right? Then AB belongs to R, BC belongs to R, then AC belongs to OK. So this is equivalent relation. R is equivalent relation. Can you say it is not equivalent relation? You can take different elements. 4, 2, 2, 2. 2, 2, 2, 4, 4, 4, 4, 2, then 4, 2 is there. Now this equivalent relation. So what is so you can partition this equivalent relation, right? So you can define P1. P1 is O1. Right? This is a partition of RE, right? So you can define like that. X 1x belongs to RP. So this 1 means 1 square bracket, so you can name it as P1. This is a set, no? This is a set. You can define like that. So what are the elements? 1 belongs to R, 1 is related to 1. So this includes 1. Okay. Then
what is P1, sir? P1.
1, 2 belongs to, here 1, 2 belongs to R. Then 2 you can take. 1, 4 belongs to R. Then 4 you can take. That's all, no? 1, 2, 1, no? That's all. Like that. Right? Then P2 you can take 2. 2 means X, 2x belongs to RE. If 2x belongs to RE, you can X belongs to this set. So very simple getting these elements, right? Very, very easy. So what are the values that X can take? Hello?
Sir, what is this? Can you explain again? 1x belongs to R.
If 2x is in this set, you can take for this set. Now you see 2x. Now 2 is there, then 2 can take. 2, then 2 4 is there, then 4 you can take. Right? Then 2 1 is there, 1 you can take. Right? That's it. Same set, no? P1 and P2 both same. No? 1 square bracket 1 equal to square bracket 2. Same set, no? This again 1, 2, 10. Okay. Then
Sir, 1x and 2x is they completely different, sir? 1x and 2x.
1x means if 1x belongs to RE, x is taken to this set. Very simple. Now, for example, 1 belongs to 1 belongs to R. Then 1 is taken to this set. Okay. Now 1, 2 belongs to this set. Then 2 is belongs to this set. 1, 4 belongs to this set. Then 4 is belongs taken to this set. Right? But likewise, what do you mean by square bracket tree? Square bracket tree means x, Px belongs to R, T. Then what are the elements you can take? T. T is below. Then T you can take. T. Then no any other element. That's all, no? Only one. What is P4? P4 you can take 4. What is that? 4x. So, x, x, x belongs to in 4x. 4x belongs to R. These are known as equivalent classes. Equivalent classes.
Can you explain the P3 again?
P3 again. So P3 means x, Tx belongs to R. Now, what are the elements that x can take? Fill. So that 3x belongs to R. Can you tell me?
Here is only 3, sir.
Can you take 2 here? Can't take because
No.
3, 2 is not here. Not available. 3, 2. 4x, can you take any other element? Let's say 4. 3, 4 is there. 3, 4 is not there here. So you can't take 3. But if you take only 3, 3 is there. Right? You can, if x is 3, then 3, 3 belongs to RE. Okay? Then you can take only 3. For x you can take only 3. That is this. Okay? Is it clear? Likewise, this square bracket 4 or equivalent class 4 means x, 4x belongs to R. Then what are the values that x can take? 4 is there. 4 you can take. Then 4, 2 is there. Then 2 you can take. Then 4, 1 is there. 4, 1. 4, 1, 1, 4 should be there. Yeah. This should be equivalent. So if 4, 1, 4 is there, then 4, 1 also there. 1, 4 is there, 4, 1 also there. So 1 you can take. Okay. Right. Because this should be symmetric, no? Equivalent class should be symmetric. If 4, 1 is there. Now,
1, 4 is there, 4, 1 should be there.
yeah. Then P5. 5. What is that? 5, 1. 5, 1. 5 means, this means x, 5x belongs to R. What is that? 5. Only you have this one, only 5. Single element. Then P6 is 6 equivalent class X. 6x belongs to R. So again, this is equal 6, 1 is the other one. Only 6. Only 6. Then P7, 7. You can't use curly bracket for this, square bracket always, equivalent class. This is a set, right? This is a set denoted by this is just a symbol, Hmm? That's why I use P letters, otherwise you will misunderstand. Because set also denoted by this symbol 7. Square bracket 7.
This is not set, sir.
This is a set, but this is not a set of single element.
Okay.
This is just a actually instead of English letters, this is taken. Keep in mind. Curly square bracket normally you have used when you represent equivalent class. X 7x belongs to R. Only one is 7. Okay. Likewise, P8 is also you will get only 8. Only 8. But if you look at these equivalent classes, right? Equivalent classes, all equivalent classes are disjoint. Okay? Disjoint. Disjoint means no intersection. Or equal, completely equal. But you see this, now you have 8 equivalent classes. 8 equivalent classes. Out of these 8 equivalent classes, 1 equals 2 equals 4. Right? 1 equals 2 equals 4. And others are unequal. But if you take P1, P2, then P3, oh sorry, 3,
For P8, you just write the X.
4, 5, and 6,
So what you writing, sir?
7, 8. All these are not equal. Okay? That means always equivalent classes are disjoint or equal. Equal. Okay. But you know that equivalent class 1 contains 1, 2, 4. Then equivalent class 2 also equal to 1. 4 also equal to 1. Right? Like that. So this is a partition. Partition. Partition means, so you just partition. Now if you take partition, uh, what do you mean by partition? Equivalent class partition, that is hello?
Hello.
Yeah. Hello.
Tell me, sir,
කීයට දන්නේ මම හෙට කියන්නද පොඩ්ඩක් බලන්න. Right, if you take now this partial, if you take now this is Venn diagram, eh? Venn diagram. This is just like a partition of a land. Okay. Partition of a land. Okay. 1, 2, 4. Right. Then 3. 5, 6, 7, 8, like that. So this is a partition. Why we call partition? There is no intersection between these sets. This is a Venn diagram. This is set A. Set A. Set A is partitioned into how many sets? 1, 2, 3, 4, 5, 6 sets. 6 sets. Right? So you have to get an idea from the equivalent classes. Always equivalent classes are disjoint. That means no intersection. Either equal or disjoint. If you take any two equivalent classes, for example, if you take 1 equals 2 equals 4, these three classes are equal, right? But other classes unequal, right? Okay, all these three classes are equal to 1 to 4. Is it clear? Right? Equivalent class. If you take any equivalent relation, based on equivalent relation, you can then entire set can be partitions. Okay, it's equivalent classes. But how do you, same method, how do you apply for set of integers? If the parent set is set of integers, I think we discussed earlier this in different way. When we discuss divisibility, okay? A equals B modulo N. Can you remember? Hello?
So divisibility.
Yeah. Partly. Let's take, now we are going to discuss, now we choose parent sets as set of integers, right? And define, then this infinite set, right? This infinite. Okay. Then define a relation define a relation capital R so that it is also infinite set, right? So you can define a relation R so that it is also infinite set. How did you use that? So can you tell me relation? So you can define like that. X, Y, yeah, X, Y belongs to X and Y are integers. Hmm?
So did you like define a relation, or what's that?
Hmm?
So define what?
Define a relation.
Uh,
Define a relation R so that it is also infinite. Hmm? So how to define relation? So we discussed many relations. Have you defined relations? X minus Y is divisible by 5. This you can very easily prove this equivalent relation. Hmm? Reason equivalent relation you can do it. You can show this relation is reflexive. You can show this relation is symmetric and this relation is transitive. Okay?
yes, sir.
Therefore, this R is equivalent relation. If it is equivalent relation, you can separate into equivalent classes. Okay? Equivalent classes. Now let's see equivalent class one by one. So maximum of, you can take only 5 equivalent classes for this. Maximum is 5 equivalent classes. Let's see how you can do that. Now if you take X, if A is equivalent class A is defined as X AX belongs to R. That is how you define equivalent class A. If A is defined like that, then according to this definition, what is 1 or 0? What is 0? First of all, you can take 0. 0 means X if 0, 0x belongs to R. Is it clear? Right? If 0x belongs to R, then 0 is equal to R. Then what are the elements of this? Can you take, if 0, 1 belongs to 0, 0, 0, 0 belongs to this R, no? Because 0 minus 0 is divisible by pi, no? 0, 0 belongs to R. Then you can take 0 here. Can you take 1 here? Can you take, uh, can X take 1? No, because if you take 0, 1, 0 minus 1 equals minus 1. This is not divisible by 5. Right? Okay. Then if you take 0, uh, then 5 you can take. 10 you can take. Right? Minus, then 15 you can take. Right? So minus values also you can take like that. 15, 20, 25, 30. So all the multiple of 5. Right? All multiple of 5. And negative values also minus 5, minus 10, minus 15, minus 20. All these you can take for this set. Okay? So these are multiples of 5. Then if you take equivalent class 1, x, 1x belongs to R.
This is divisible by 5, sir.
Yeah, divisible by 5. Now what are the values that x can take? Can you put 5 here? Can't. 1 minus 5 is not divisible by 5. You can put 6 here, no? Can you put 1? Yes, 1 you can put. Then 6 you can put. Then 11 you can put. 16 you can put. 21 you can put. 26 you can put. Minus 4 you can put. Minus 9 you can put. Minus 14 you can put. So these is it. These are multiples of, what is that? Multiples of. These are the arithmetic series, no? Common difference is 5 again. This also arithmetic series with common difference is 5, right? Like that. Then 2x, 2x belongs to R. So this includes,
Sir, I'm not doing, sir. 1x belongs to R, sir. So in the place of x, it will be, sir.
that means in the place of x you can put 6, you can put 11, right? You can put 16 here, right? Okay?
Yes, sir. So 1 minus 1 is 0. 1 minus 6.
Minus 5 is divisible by 5.
Yes, sir.
1 minus 11 is minus 10 is divisible by 5. Then 1 minus 4 is plus 5. Plus 5 is divisible by 5. If you put minus 9 here, 1 minus 9 is 10. 10 is divisible by 5. Like that. For this one, 2, 7, 12, 17, 22, 27, like that. Then minus 3, minus 8, minus 8, minus 16, right? sorry, minus 11. Ah, no, minus 30, minus 30, minus 80, like that. Okay. Then T equal class T means H, TH belongs to R. Right?
That is minus 13, sir.
Yes, minus 30. Yes, minus 30.
So it will be like 2 minus 13, sir.
Yes, that's minus 50, plus 50. Plus 15 is divisible by 5. Then this one, 3x. You can take 3, then H, 30, 80, like that. Eh? 23, like that. Now if you take 4, H, 4x, so this will get 4, 9, 14, 19, like that. Now what do you think about 5? Hmm? What do you think about 5? You are okay, here. Kailangan mo yung subject. Kailangan mo yung subject. What do you think about 5? X, so 5x belongs to R. Then uh, 0 you can take, 5 you can take, 10 you can take, 15 you can take, 20 you can take, like it. This same as 0, eh? Okay, same as 0. Okay, 5 equals 0. Then if you calculate the 6, 6 equal to 2. If you calculate 7, 7 is equal to 3. If you calculate 8, 8 is equal to 4. If you calculate right, sorry, this 1, 1, this 2, this 3, 1. 6 is equal to 1. 5 is equal to 0, 6 is equal to 1, 7 is equal to 2, is equal to 3, right? 9 is equal to 4, again 10 is equal to 5, 5 is equal to 0. Okay, right?
That is not right for 6.
But all these are infinite sets. No, these are not finite sets. These partitions are finite, infinite partitions. But only how many partitions are there? Only 6 partitions. Sorry, 5 partitions. Only 5 partitions. What
So
are
can
the
you
partitions?
tell about 5 at the end you wrote 6 equal to 0?
Hmm?
What
Yeah.
does it mean, sir?
Yeah,
5.
5, if you calculate 5, you get 0, 5, 10, 50, same thing. Yeah. It's same. Same thing. Now, likewise, if you calculate 6, you will get this set. Okay. Therefore, we have only 5 partitions, right? Not more than 5 partitions. All these are infinite sets, right? So that's all. These are not equal, right? These are not equal. All these are unequal, right? There are 5 partitions not equal to each other.
No, I did not get why we put at the last is equal to 0
Hmm?
for 5.
Because you get same set of elements. Hmm? Same sets of elements. 1, 2,
5 minus 1.
0, 3, 4. These are the 5 partitions, only 5 partitions. Not more than 5 partitions. Right? Not less than 5 partitions, only 5 partitions. So if you take these entire set of integers, this is set of integers, so you can divide into 5 partitions like this. 1, 2, 3, 4, 5 like that. 5 by 1, 2, 3, 4, 5. Right? This is also infinite set, this is also infinite set. All these 5 are infinite set, this is also infinite set. This partition is also infinite partitions. Why we call infinite partition? Because each partition contains infinite number of elements. Okay? Is it clear? Right?